All right, good morning or afternoon or night or whenever you're watching this video. This is video number 10. And this covers chapter 3, sections 3 and 4. And these are all about slope of a line. All right, so let's talk about some review and stuff that you probably already know. Slope is represented by the letter M. And there is a formula for slope, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's also sometimes referred to as a change in y's. This is a symbol that represents the word delta, and it means change. So delta y over delta x, or change in y's over change in x. And then we also refer to slope as rise over run, right? So there's just some little pieces of information. There are 4 different types of slopes that we can classify. And it's important that you are aware of how these look so that you can quickly look at a graph and go, oh, I have the wrong slope. So draw yourself 4 different little coordinate planes here, just little sketches, because we're just going to put some quick lines on them. Okay. And the first one, I want you to draw a line that starts on the left and goes up and to the right. And this represents a positive slope. Okay, that positive slope goes up and right when you go across the line. And if you think about, if you go up on the y-axis, that's a positive direction. And if you go to the right on the x-axis, that's also a positive direction. So your rise over run is positive over positive, which has to be a positive slope, right? Okay, the next one is going to start at the top and go down and right. And this is a negative slope. And it goes down and right. And then, as we just mentioned, with this guy, as you go down, that's a negative. But as you go right, that's a positive. So your slope rise over run is a negative over a positive, which is indeed a negative slope. Okay, well, what happens if you have a slope that just goes horizontally? So this is a slope that you would classify as a zero slope, and that is because it has no rise, but it has run. And so if you look at that, you would have no rise, which is 0, over some number of run, and 0 divided by anything is 0. And so a horizontal line is always going to have 0 slope. And also, so let me go backwards just a little bit. We know that an equation of a line is y equals mx plus b, right? Well, that's how a positive line would look. A negative one is going to be y equals negative mx plus b. All right. And then if you have a 0 slope, this is just, that means that this x would be 0, right? So you're just going to have y equals b. There is no mx. It's 0. Okay. And then this one over here, what if you have a vertical line? Well, a vertical line has what we call an undefined slope. And let's look at why. That has an undefined slope because it has rise, but it has no run, which means we have some number for the rise over 0. And can you divide a number by 0? No, you can't. So this is called undefined when you have 0 in the denominator. And so any vertical line will have an undefined slope. And the equation of this line, there is actually, the y is the same everywhere. So this is x equals some number if you see a line that looks like that. So it doesn't even look like y equals mx plus b. Something like, this will be like x equals 2. And so if you had x equals 2, you go through the x-axis at 2, and the y value is the same everywhere. Or I'm sorry, the x value is the same everywhere in that line. So there is no y, and you have an undefined slope. All right, so 4 different types of slopes: positive, negative, 0, and undefined. All right, also, really quick note on an undefined slope. In varsity, if you have an undefined slope, you will write DNE for does not exist, okay? So whenever you have a slope that is undefined, meaning you get 0 in the denominator, right? That's when it's undefined. Then you're going to write DNE as an answer, okay? All right. Couple more little tidbits of information about slope. Parallel lines. They rise and run at the same rate, right? So they have exactly the same slope. Okay. And would those lines ever intersect each other? So if I had 2 parallel lines that are going to rise and run at the same rate forever and ever and ever, these will also never intersect, right? All right. How about perpendicular lines? That by definition means that they intersect at a 90-degree angle. That does not mean that they sit like that or like that, right? They could sit like this, and there's the 90-degree angle. So they could sit anywhere, but they intersect at a 90-degree angle. And where parallel lines have exactly the same slope, perpendicular lines, they have opposite. And by opposite, we're talking about signs. So one's positive and one's negative. Opposite reciprocal slopes. Do you remember what the word reciprocal means? A reciprocal, if you don't know, you should probably add it in here. That is a flipped over fraction. So let me give you a real quick example. If I had a line that has a 2/5 slope, the perpendicular slope would have an opposite sign, flipped over fraction, and these would be your perpendicular slopes of 2 lines. What if I had a line that has a -3? Well, its perpendicular slope, technically this would be 3 over, right, 1. So its perpendicular slope would be a positive, flipped over fraction, 1 over 3. These would be perpendicular slopes. That's going to come back in another lesson somewhere else. Okay, so let's take a look at actually finding the slope of something. Then I want to show you a couple of problems in varsity and just make sure that you're good. So using the slope formula. Which remember is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And these are little numbers, subscripts. They're not numbers right next to it. It's not y2. It's not y squared up at the top, right? They're subscripts, not superscripts. So make sure that you're careful about that. All right, here's an example of a problem. Find the slope of the line through the points 1, -5, and 3, -3. Okay, so based on the formula, one thing I like to do is first label these things. So, well, how do you label them? Any ordered pair is an ordered pair xy, right? So I take the first point and just label this as x1 and y1 because it's the first set of xy's, and then take the second point and make that x sub 2 and y sub 2. And now I'm simply going to substitute into this formula, which I'm going to rewrite down here. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's fill some stuff in. Y sub 2 is this point right here. So that's -3. Make sure you include the minus sign from the equation. And y sub 1 is this -5. I would enclose that in parentheses just so you deal with this double negative here. Put it over. X sub 2 is this 3 over here. So 3, make sure you bring the minus over. And then x sub 1 is that 1. And then you're just going to simplify. So here, the first thing I would do is deal with this double negative, and a minus is a plus, right? So now I have -3 plus 5, which is 2. And on the bottom, I have 3 minus 1, which is 2. And always simplify to either a proper or improper fraction, but 2 over 2 is 1, and that would be your slope. Okay? I'm not going to go through a million of these. If you end up with a 0 on the bottom, remember that it's a DNE. If you have a 0 on the top, you have a 0 slope, and you need to put 0 so that I know that you know that it's 0. Okay? And then there's a problem in varsity. I want to take you out and take a look at it. We're going to look at number 11. Number 10 is kind of similar, but here's number 11. Oops. Here's number 11. It says, solve for A if the line through the two given points has the given slope. So they give you a point that has a variable in it. They give you another point with a variable in it, and then they give you a slope. Okay, so we're going to set this up, and okay, so we have -2, -5, -5a. I'm just jotting these down so I can go write them somewhere else. And then 1 and 4a and m equals 6. Okay, so let's go work this out. Your job is to find out what a equals here. Okay, so the problem is given the points -2, -5a, and 1, 4a. If m equals 6, find the value of a. Okay, so what we're going to do is use the formula. And solve. So we know the formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's fill in what we know. M, excuse me, is 6. So I'm going to actually write that as 6 over 1 in case you have a fraction. I mean, m is a slope, rise over run. And then I'm going to fill these in. Y sub 2 minus y sub 1. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so now let's go ahead and simplify if possible. So combine like terms. That's the first thing you want to do here. I'm going to keep the 6 over 1. 4a minus a negative, so that's really adding, is 9a. And then we're adding on the bottom also, so 1 plus 2 is 3. And when you have a ratio, you can cross multiply. I want to make sure that when you cross multiply, you actually cross multiply and write an equation. That is the point of cross multiplication, but it seems to go away in lower grades somehow. They don't really teach this to you correctly. So we're going to cross multiply. 6 times 3 is 18. Bring down the equal sign. 1 times 9a is 9a. That's how you get an equation. That's the purpose of cross multiplication. And now you're going to solve. So a equals 2. Okay? There's a couple of these in there, and if you don't have like terms here, let me show you what I mean. Okay, so if you have the points -2 and -5, this is probably going to come out ugly, and you have the point 1 and 4a, and your slope is 6. So this is almost identical to the problem up above. The only change I made was right here. I took the a out of that. Okay. Here is what we're going to do with that. We have slope, y2 minus y1 over x2 minus x1. So now I have 6 over 1 equals y2 minus y1. I'm just going to make it a plus 5 right off the bat. And then x2 minus x1. 1 minus a minus 2 is 1 plus 2. All right, so now when I simplify, I can only simplify here. I don't have anything I can do with these like terms up here in the top right side. So I have 6 over 1 equals 4a plus 5 over 3. Now when you cross multiply, if you have multiple terms, put this in a set of parentheses, and then I would multiply here. So I have 18 equals 1 times 4a plus 5. Now in this case, the 1 is super unimportant, right? But if this 1 was any other number, your next step would be to distribute and then move the constant and then solve. Okay, so I think number 10 is like this, possibly. So I just want to make sure that you're prepared. All right, the last problem that I want to do is just to talk through, I think. And, whoops, wrong. It's problem 15. And in here, it just says, given an x and a y intercept. Well, remember that means that that's where the graph crosses those axes. So if you were to just take the line and plot these, if you have an x-intercept of 3, that means you go to the x-axis and you put a dot at 3. And then you have a y-intercept of 3 also. So go to the y-axis and put a dot on 3. And that would be that line. And then you can just count the slope, right? Or technically, I guess if you really wanted to make this difficult for yourself, you could write the ordered pairs here. This would be 0, 3. Oh, geez, bad things are happening. We're just going to run with it. Ignore this other line that is happening. I'm supposed to have a pen. And this is 3, 0. You could actually take those points and plug them into the equation. Nope. Slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Some of my students like to make things way harder than they need to be. So if you're not that kid that wants to actually count those, your slope would be down 3 and over 3. You could just do that. Or you could plug everything into that formula. I just want to, again, make sure that you're aware that an x-intercept means that there's a dot on that axis at that point. Okay? So that's it. As a result of these notes, we're going to be able to do varsity 3.3 and 3.4, as long as this is algebra 2. And I'll talk to you later. Toodaloo. We'll talk about issues in class if you have any of them.